Cross-validation tests model performance on multiple data splits. Welcome back to my channel. Hope you all are doing good. Today we are going to talk about on how we are going to perform the steps which we discussed during our last video. All the cross-validation steps. We will implement that in the real world scenario and check on how we are getting the accuracy and all of all the models. So let us start. Let us talk about on how our cross-validation works. So before moving ahead, what is the first step, guys? We have to understand our data set or the type of data which you are working. So here in this particular cross-validation example, I have taken a regression model, like we are going to work with a regression and we are going to understand all the accuracies and metrics using the regression. And here the data set which I have taken or which I have considered is the CO2 emission. So what is the CO2 emission here, guys? The study. So the study says that if like the amount of vehicles which are which are there on road, what is the amount of CO2 they are emitting, and all the features have been considered for the study. So those features are here. Let me take you to the head part of it. So these are the features. If you see Acura, make, these are the different makes. Then models, then different vehicle class. We have compact, SUV, then the engine size of that vehicle, number of cylinders, right? We have cylinders or for or the heavy vehicle, we can say, right? Then transmission type, then fuel type, then fuel consumption per city, fuel consumption per highway, fuel consumption combined. That means city and highway, and this is a kind of rating. Then fuel consumption, this is an MPG, and this is the CO2 emission. So if we'll see this table, so here the different, like all the abbreviations and everything, whatever have been used, the meanings are present in this. So if you'll read through this, you should be able to understand what exactly are the variables or the the understanding of the variables. You can get it. So the first is model. So model, there are different types of model that have been taken care. One is a 4WD or 4x4. It's a 4-wheel drive. Then AWD, all-wheel drive. Then FFV, flexible fuel vehicle. SWB, short wheelbase. LWB, long wheelbase. EWB, extended wheelbase. Transmission type A, automatic, then automated manual, automatic with select shift, then continuously variable manual, and we have number of gears at the same time. That means here, right? For example, if you see AS5, AS5 means it's automatic with select shift and the number of gears are 5. So it's a combined one. Transmission is and they have considered. Then fuel type, we have gasoline. Okay, X means gasoline, Z means premium gasoline, D means diesel, E means ethanol, N means natural gas. And fuel consumption, again we have seen that we have city and highway fuel consumption ratings are shown in liters per kilometers. So these are the ratings, my bad. These are the ratings, and the combined ratings or like 55%, then 45%. Is shown in liter per 100 kilometer and in miles per gallon, like MPG, right? So all these things are there. Then CO2 emissions. This is nothing but the tailpipe emissions of carbon dioxide in grams per kilometer for combined city and highway driving. So this is the one which is taking control over the CO2 emissions, right? So we understood our data. Now we will see, let me run through this so that it will be easier for, let me run through this. So we got it. Now what is the next step? We are going to understand the info part, right? So this is my info. What my info is saying, we have, it is saying that we have, different entries, right? How many entries or how many rows are present. So here we have 7,385 entries, or if you see the index is ending at 7384. Then the data types present here are object type, then floating type, int type, right? We have different objects. different type of data types. Then what is the next step? We are understanding the describe part, right? The descriptive statistics part. Okay. Uh, then we have, like, what is the next step? Once we understood everything, we understood, okay, if we see the mean of this engine size, it is coming 3.16 cylinders, this. Then if we see the CO2 emission, this is our target. So just observe this because this is going to be useful. Just observe this. The mean of CO2 emission is 250.58 and STD is 58.51. Just observe this, then we will understand the further part. Then what is the next step, guys? We have to check whether we have any duplicates present or not. So for that, I have taken my drop duplicates and I am printing my data along with it. So if we see the original data set, we have 7,000. Where is it? 7,385. So however, after removing the duplicates or like the repeated lines, right? Duplicates means the repeated lines. Some lines might be repeated in that. So it has come down to 6,282 rows, right? Now we will see whether we have any null values present or not. So all are coming zeros here, right? And so with this we got our, and let us understand the shape. So this is my final shape which we are getting after removing or after understanding whether we have null values or not. Then we have the data info part we understood. Then we have we got our duplicates removed. Then this is the final one. Now this is my columns. These are my columns. Now when I am observing that my consumptions are there in a combined format, right? I have my combined consumption rating is there. Then do I have to keep the city and highway just for redundant? Because for feature selection, right, this is important. You have to take a guess on which features you have to keep, which should not. So for that, so do I have to keep my city and highway? According to me, it is not at this case because I have my combined fuel consumption rating already and the MPG part also. So I can remove them or I can drop them as a part of my feature engineering. So I am going ahead and I'm dropping them. So this should be my final head. Then what is the next step? At this step, you can go ahead and understand the heat map part if all are numeric. But however, I have my make, my model, my vehicle class, everything as my object type, right? So if we want to see the uniqueness of that, so you can check that part as well. Data dot make dot unique. Oh, we have these many unique values. If we'll see the count, okay, just if we'll remove this. So I have 6,282 unique types are present. Okay, no, I think this is telling me the total number of unique. So these many unique values are present for me. Okay, then if I'll go ahead and understand my model we understood already, right? In the top section we have seen some 5 or 6 models. Yeah, we have ILX hybrid, MDX. The shape is 2053. Okay, so there are 2053 unique values are present for model. Okay, so we understood all these things, right? Now we can go ahead and let me just get the vehicle class unique values as well. Okay, let me just get vehicle class data dot vehicle class. Okay, I just need to take like this. Vehicle class dot unique. So we have these many unique types for vehicle class as well. So then we have transmission type data dot transmission. So you can understand the difference here, right? What I have done here and what I am trying to do here. So if we'll see one thing you can observe here. So wherever my single word is present, you can directly take or you can directly iterate or get your objects or the models like this or the values like this. However, if you have any space, you should consider that as a array kind of thing. So because this is my list, the list of values, right? So out of my list, I am taking one value here. So this is how you can present because I have my space. If my space is not there, again I was trying to get my data dot transmission in this way, right? Then we have fuel type. So let me just get my fuel type unique values as well. Fuel type. So we have like the way we have seen on the top section right now during our data understanding. So these are my fuel types. So we understood everything, all the unique values and all. Now we can go ahead and okay. I need to grab. Okay. I need to grab. Yeah. So now we can go ahead and convert them to our numeric because these are my categorical values, right? That is the next step. So I have taken my ordinal encoder and I have taken all my data, the categorical variables, and I am going ahead and my converting. So after converting, this should be my head. So I have just taken the head of 20 because I wanted to show you that you can see the vehicle class. We have so many, right? So the transmission type also we have so many. So you can see the number went up till 22, 25 like that. So even here also the unique one, it is like the highest till now we have seen at 13, 11 like that, right? So this is how we have converted our data to numeric. Now what is the next step? After getting converted, what is the next step we are doing? We are understanding the correlation between the variables with correlation matrix or the heat map. So this is nothing but a correlation matrix, right? Okay. So here we will directly come down to the last row, right? This is my last row. And with this, we can be able to understand everything which is having high correlation, which is not having correlation, because my target is this one. My target is not this one. If I'll consider this, then this should be my target. If I will consider this, then this should be my target. Then what we are understanding here? My make is negatively correlated with CO2 emission. Then model is somewhat related. It's not highly related to CO2 emission. Then vehicle class, it's moderately related and it's a positive relation. Then engine size, which is 0.85, and it has a good correlation. Then cylinders, it has very good correlation. Transmission, negatively correlated. Fuel type, it is it is not having any correlation with CO2 emission. Then the highly correlated element here is your fuel consumption and the fuel consumption in MPG. So the combined one, if we'll see, is showing 0.92 with CO2 emission, and the MPG part is also showing a negative correlation, but however there is correlation present. So we understood this table, and we want to see the different correlations with different features. For example, cylinders, right? Cylinders with engine size. You can see cylinders with engine size is coming 0.93. Then transmission with engine size is coming minus 32, minus 0.32. Then fuel type with engine size, it's not having much effect, so 0.05. Fuel consumption combined with engine size is 0.82. Then fuel combined minus 0.76. So this is how you can read. But however, we understood, okay, with our CO2 emission, we have engine size, vehicle class, cylinders. Then we have, the combined fuel consumption combined are taking big role. Now we will understand the behavior of each variables, right? Like we have the univariate variable, we have bivariate. So all those behaviors, we will understand that. So the first thing what we are understanding from here, that there is a relation. We can see the engine size. Let me just see the engine size and cylinder. You can see we have 0.93 relation, right? So that is a good correlation. Let's see that. So this is the scatter plot I have considered, and in the scatter plot I can see that there is no outliers. The data looks good, and here this is how it is coming up. And then the next one I have taken engine size with CO2 emission, because it's a proportionate thing, right? Because if the better the engine size, the CO2 emission will be lesser, right? So those kind of understanding will be there, and for that, due to that reason, I have taken in this way. I have taken the scatter plot. If I'll see the data looks good and I am not seeing any outliers, because the engine size I have seen they are bigger, right? We have seen the bigger engine sizes as well in the data set. And let me just remove this. Now I want to know the transmission. Now we can get the hue part coming into picture. And what is hue, guys? I have already told you during our Seaborn scatter plot. Hue is the one based on which it is going to be dividing the data. For example, here I have taken my cylinders. So according to my cylinders, my data is going to be divided. My transmission and CO2 emissions are going to give me the output. And this is my legend, right? So if I'll run this, or it's already there, I do not have to run again. If we'll run, let me run this again. It takes time to come. So if you see, this is my transmission, this is my CO2 emissions, and if you see the color coding, right? This color is having 5 cylinders, then we have 7 cylinders, 10 cylinders, 12 and 15. So based on that, whole of my data is getting divided. That's my hue part, right? Then the same hue part, I'm taking cylinder and I'm getting my fuel type and CO2 emissions, because CO2 emission is our target here. And we can see like we are getting the data in this way, right? You can see that we have cylinders and fuel type. So fuel type, we have different fuel types, right? 5 types of fuel type. So based on the cylinders, the fuel type it is showing. Then we have hue. I am taking fuel type. Then I am taking the cylinders, and if you see, this is how I am getting this is the way I am getting the output. And now I am understanding the cylinders type or the count of cylinders, right? With count plot. So you can see that the 4 cylinders type is having the highest count. Just observe the numbers. The cylinder types 4 is having the highest count. Then if I'll come down, vehicle class. So if you'll see the vehicle class, again, the vehicle class which is having, the vehicle class 2, the vehicle class 0 and the vehicle class 11 are having the highest count here. Then I am going ahead and understanding my box plot. So this is my box plot, and this is how my data is coming up, right? And you can see, it's 210. That's fine. And if you'll see this 400 to 500, my data is coming up. So again, it is up to you. If you want to treat the outliers, these are not extreme outliers, guys. So we can understand, like we can go ahead and use them in our study. Then what is the next step? What are the 3 things or 4 variables we have got in our heat map, right? I am going ahead and understanding the relation or by using the reg plot. And if you see the reg plot, we saw that vehicle class is moderately related, right? So you can see it's not so steep line. It's just like this, somewhat tilted. And if you see the engine size and CO2 emissions, it was really good correlated, and we can see the output here, right? Because the number was saying that. Then cylinders and CO2 emission, you can see it's a good relation. Then we have the fuel consumption combined. You can see it's negatively correlated. We saw that we have some minus 0.92 or some value came. Then for reg plot, fuel consumption combined liter per 100 kilometer, that was positive 0.91 or something. So we are getting a strong correlation with this. So we understood everything now. As point of your data exploration and everything we understood, and the correlations. Now we will go ahead and analyze our data on cross validation, right? So what is the first step we are doing? We have to get our independent variables and dependent variables. So this is my independent variable, right? Independent variables, right? And this is my dependent variable. Dependent variable. So if I'll run this, I got my independent and dependent variable combiningly. Then what will do that? We will go ahead and get our first. We are going ahead with k-fold because that is the important and most used, cross validation which we are performing in our every, like in most of the models. Either it's a regression or classification. K-fold cross validation. We understood that in theoretical part. Now we will see what are the factors, what are the things are getting used here during our practical point of view. So k-fold is present in model selection. Just observe this. K-fold is present in model selection. And model selection, what are the other things present? We have train, test, split. That is also present in this, right? However, we are going ahead with k-fold. We are not going ahead with train, test, split. Keep it in mind. We do not have to use, in case of cross validation, train, test, split. We are going ahead directly with k-fold. Then with k-fold, we have to get a cross validation score as well. What is the score we are getting? Usually we are getting R2 score. Here we are going to get cross validation score. Then let me run this. Then I am going, because I am using my linear model, so linear regression. I am getting my regression model first, right? This is my model. I have initialized my model, right? Linear regression. I have taken my model. Then I am going ahead and getting my k-fold cross validation. And let us understand that we have k-fold and this is my object of k-fold, right? This is how our object and class concept is coming into picture, correct? So I have taken my k-fold. Inside that I have taken n splits. That means I am telling my whole data set, my whole test data set is going to be split into 5 parts. Then I am telling my shuffle should be true. Then my random state should be 42. Now what is the next step? I am getting my cross validation score, and for cross validation score, you can just take the model. This is how we can get it. Let me run this first. Let me run my k-fold first. Then cross validation score, you have to take cross validation score. Then inside that you have to pass your model. You have to pass your independent variables, then dependent variable. Then your cross validation is what? Here my cross validation type is my k-fold. So I am passing my object here. Then scoring again is a factor here. So here I am telling my R2 score. I am telling my R2 score should be judged. So I am running. Then after that I am printing my R2 score. Then I am getting my mean R2 score out of it. Now let me run this. And you can see that I am getting my R2 scores. Then my R2 scores, these are my R2 scores for what? For my 5 different models which I have taken. Right? I have taken my 5 splits of my whole data set. Right? And these are my different R2 scores for those 5 models. So one R2 score I am getting, like one I am getting 90.9% accuracy. Another I am getting 91.4% accuracy. Third iteration or the third fold when I am going ahead, I am getting 91.7 accuracy. Fourth I am getting 91.4. Then final I am getting 92. So which is my great score if you see. However, when we are considering the overall score, because this is how, right, this is how we are getting, even now in during our theory we have understood, okay, this is how the final average we have to get just to understand how the model performs. So this is my mean out of it I am getting, and that mean I am getting 91.5, which is a good score if you see this. Because of cross validation we got that. Now we understood, okay, how my scoring part comes into picture. Now we will see how my accuracy part will come into picture. So for that, there is a method or there is a model, make scorer, and make scorer is present again in your matrix. If we'll go ahead and see a scalar matrix, make scorer is present there, and make scorer is what? It's a initializer. You can say it's an initializer, and that initializer, what it is doing, it is going to take each accuracy inside it, and it will evaluate. So here I am telling I have to take my MAE, mean absolute error score. So for that I have assigned one variable, MAE underscore scorer. Then I am taking my make scorer, right? Then I am going ahead, I'm telling mean absolute error I am passing. That is my accuracy method I want to know, right? Then greater is better. Here in case of mean absolute error, the lowest mean absolute error is the greatest, right? So here I have to put this factor false, because I do not want the greater amount here. I want the less amount here, and based on that it is going to evaluate. Here I have said that, okay, it's a wrapper, right, or it's a method or initializer, make scorer. I have just said that the same thing here. Then I am going to get my MAE score. So here I am getting my MAE scorer, and I am going to get my MAE scores. So this is how, right? Like in case of cross validation, we have to initialize the cross validation in this way, cross validation score, and you have to get your score with this. So again, on the top side, what we saw how we are getting your R2 score. That's a direct one. But however, in case of mean absolute error, we are defining a mean absolute error scorer, and we are passing it in the scoring. So the same thing, you can see model I have passed my independent variable, dependent variable. CB is my cross k-fold, right? And scoring MAE scorer. The whatever I have got my value here, the same thing I am passing here. Then I am getting my MAE scores, then the mean scores out of it. And if I'll print it, you will see all values are coming as negative, and this is how the output you will get when the model is going ahead through different iterations and all, because internally what it is understanding that, okay, if I'll put negative, right, if I'll put negative value, it is very easy for me, because if we'll see in case of negative, what exactly we understood, it will see -3 and -5, which is better. -3 is better. So with that, the visibility of the value will be less for the model. That's why it is considering a negative value internally. And if we see that, if we see in everything, this is the good score I am getting, right? Because these are the highest. If we'll see in the negative perspective, this is the good score I am getting, and this is the mean score. And while getting mean score, I have removed my negative, because I want to use that for my judging of my predicted value, right? Then I understood my R2 score, I understood my mean absolute error. Then I can go ahead and understand my mean absolute error and mean square error and RLSC. So in case the mean square error also, we do not need a greater value. So for that, greater is better should be false. And I'm telling, okay, I want to pass. Again, the same logic. Make scorer, we have to use mean square error. Then cross validation score, we are passing my model, my linear model. Then my independent variable, dependent variable. Cross validation is my k-fold. Scoring is my MSE score. The same thing, whatever I got here. And here again, I'm getting my negative values and I'm getting my mean value and my RMSE. And why we are getting mean value more, guys? Because in your data set, if one value is having large error, it's going to improve, maximize your score. That's why you are getting larger value in case of mean square error. Then we will see how fold wise our performance happened till this time, right? Let's see that. So now we will understand k-fold cross validation loop. So for that, as I have taken 5 folds, right? I have taken 5 folds, so it has to happen 5, or it has to iterate 5 times, right? So for that, I am initializing 1 because it cannot be 0. First fold cannot be 0, right? It should be start with 1. Then I'm telling, I'm trying to understand my MA scores first, mean absolute error for this. So I have taken one metric just to understand how my k-fold cross validation behaves. So for that, I have taken my MA scores. And this is a list, right? Again, I am getting my 5 MA scores. So I have to iterate through that as well. So for that, I am taking my train data set, then my test data, then inside kf.split, I am just splitting it. And while splitting, I am telling my independent data, right? And that independent data, I am considering X train, okay? And I'm telling my ilog. This is my column values here, right? Train IDX, then test IDX, then Y train and Y test. So this is how I am getting my data. Then I am fitting my model here. I'm fitting my model here. While fitting, I have to take what? X train and Y train, right? Because I'm fitting my data, or I'm training my model with train data, right? Then after that, I'm predicting my data. For predicting my data, model.predict, and I'm taking my test data there. Then what is the next step I'm doing? I'm doing MA, mean absolute error, and mean absolute error we know we have to get the test data with predicted data, or the actual data with the predicted data. So I have taken the same. Then manual MA scores, whatever I have taken, I am appending that value with MA. That's it. And I'm printing my data. I'm just telling what is the fold and what's the MA. And every iteration it is going to increase 1 till 1, right? Now let's see. So you can see this is the output I'm getting, manual k-fold. So in fold 1, I got the MA 11.98, right? Then in fold 2, I'm getting 11.83. In fold 3, I'm getting 11.26. In fold 4, I'm getting 10.93. And in fold 5, I'm getting 10.87. So it's reducing, which is a good thing for me. Then I'm getting my mean MA out of it. So this, like whatever we saw here on top, right? This is directly we got the output like this with cross validation score. Directly you can get, but however, the same thing I have shown you here practically, or the theoretical, fold wise how it is coming up. So you can see the same values we got here at 11.98, 10 or 11.83. Same values we got here as 11.98, 11.83. So my purpose here is to show that, okay, whatever the cross validation score method we have taken and we have passed all these values, same thing how we can achieve through your fold wise, right? So simple. Here we have taken my train and test, 2 variables I have taken, and I'm splitting my data here with independent variable, and I'm telling that, okay, X train should be this, X test should be this, like this. Then we are getting my MA score, and the same thing I had shown you. Now what is the next step? As we got our Y predicted value, right? That predicted shape, I wanted to see what is the Y predicted shape it has taken in each fold. It has taken 1, 2, 5, 6 as the shape. Then I'm printing my y predicted value. Then if we'll see then how we will get my final predicted value here guys. Our final predicted value should be 269.34 minus 11 because this is my mean MA, and every value whatever we are getting should be less than this. So if we'll see the actual output what we are getting, right, how my model is predicting, this is how it is predicting. Whatever the output I got or the predicted value I got, this is my loss, right? This is my loss, and these values we got from a loss function. So I have to reduce my loss because that's not correct. I have to get my actual value, and the actual value should be my differentiating with my loss. So the value should be 269 minus 11, and that should be my correct value, and the same should be applied for all 1 to 5, 6 values whatever we are getting. Similarly, we will understand on how my stratified k-fold works. Same thing guys, same thing. Here my you just need to use the stratified k-fold, and whatever the top section we have used, right, escape you can just use, and split and splits 5 then shuffle true. Either you can use the cross validation like this, cross validation score, you can try this. You can use cross validation score directly and you can get your outputs. However, I wanted to show you the fold wise outputs, so for that I have taken like this. Same thing, instead of kf I have just used escape, and here I am splitting x and y both. Why I have taken that guys? Because in case of k-fold you are considering the whole data set completely, like here there, but here we are taking our train like both independent data and dependent data, train and test both split we are taking. So for that reason I have taken x and y, and there also, like in case of kf, y is also getting considered. However, the logic or the input, it is not expecting a y to pass there. So here you can see the outputs we are getting in this way, right? And this the predicted output we got guys, you can see it is less, like as compared to your k-fold. Here the output is coming a bit lesser as compared to the kf. Then the repeated k-fold, right? Same, you have to use and splits 5 then and repeats 2. Here one thing you have to note it down guys. What is the repeated k-fold guys? In case of repeated k-fold, what is the factor we are considering? The output which we are taking, right? The input which we are giving, we are repeating it. Like the k-fold which we are doing, that k-fold we are repeating multiple times to get the better output or the better accuracy. So for that we have a parameter called n underscore repeats. So I have taken it 2. So if I'll change it to 3, it is going to get the that output whatever we are going to get, it is going to repeat it thrice by shuffling or by taking different combinations of input, right? So if you see this, I have taken the archive same, and I am passing this. Then I am getting my train, test, split and everything. Then this is what I am getting. I need to run this because the output I should get 15. So you can see here I am getting 15 times. You can note this one thing. So here you can see the value is reducing, right? In fold 5, I am already getting my accuracy 10.87. Again, in my fold 6, the same, whatever the fold, like in first fold till fold 5, whatever the output they got, they are again reshuffling it and again using it. So you can see that 11 point, it's changed. The data is changed now, 11.33. So the accuracy is increasing, right? Then 11.37. So it's good. It's good. Then in third fold, this is the third fold or the third repetition. Like the same, whatever the output we got in first fold or the second fold, or the combination of kf and first kf and second kf, the third kf, this is the output we are getting. 10.94, then 11.51, then 11.73. 10.95 and 11.76. So this is the combined one. And if you see the predicted output, it is way lesser as compared to our KF, which is good, right? Because we want the price should be the CO2 should be reduced. If it is a car price, we want the price should be reduced, right? Nobody is willing to pay that much price. It's not good for industries as well, if to show that much price. So this is the Y predicted value we are getting, and I have told you how we are going to judge the final output, right? We need to reduce the loss. Then this is the example of leave one out, and this is how we can import leave one out. And this is the example I have shown you. Leave one out directly. I have taken my X train X test, Y train Y test like this, and I'm just getting my output here. It is slow, guys, so it will take some time. It is very slow. You can see that it is very slow in performance. It will take a lot of time, maybe some minutes to come out. Then this is my P out. Okay, P out. So in P out also we have taken in this way, and we are getting our mean absolute error score. So again, this is also slow. So it will take some time to come. You can try with by yourselves on these things. So I have shown you all kind of cross validations in this particular example, right? And we will wait for some seconds. If it is coming up, it will take time. You can see that it is taking some time to come. Leave one out and leave P out. So what is the meaning of leave P out, guys? What I have taught you. In leave P out, we have to give 2 points. Here you can see, leave 2 points out. That means you have to remove two variables or two samples from the lot. You have to leave it. Then in case of, you can see we got our output here. In case of leave one out, cross validation, we are getting the mean absolute error. Mean absolute error is 11.37. And in case of leave P out, it takes time. So let's see. You can try it out, guys. So this is how we have come to a conclusion on how our theoretical part and how our practical part makes sense right now, right? We have understood, we have cross validation score is said that we are passing my model, my independent variable, and the type of accuracy over there. So we understood everything. Now we will talk about the further things in our next video. Till that time, see you. Bye. That is all for now. We will discuss the hyperparameter and hyperparameter tuning steps or the hyperparameter tuning process during our upcoming videos, and those are really important concepts. Do not miss them. And if you really like the content, please go ahead and start subscribing, like, share your comments, share your feedback, and while subscribing, don't forget to hit the bell icon so that you will not miss the latest updates, as the contents are going on regular basis. So you should not miss them. And see you till the next time. Bye. Take care.